In this video, I will focus on L rotational, the rotational or spin part of angular momentum of a solid object. So I do want to review the definition of angular momentum, how we can calculate it is equal to r cross p for a point particle. If I have a solid object, I can break the total angular momentum of that as the translational angular momentum, which is the angular momentum of the center of mass, and the rotational or spin angular momentum, which is the angular momentum of the solid object with respect to the center of mass. Now, you may remember, that in introductory physics we said L rotational equals I times omega. I do want to remind you again, this is a definition of angular momentum. If you want to calculate the rotational angular momentum of the solid object, you need to break your solid object into small pieces and apply this expression, because that is the definition. Now, in introductory physics, we said that L rotational can be calculated as I times omega, where back then we were saying that I is the moment of inertia and it is a simple number. Okay, that's what we said in introductory physics. Which probably gives you a hint that this is not really the case. Now, if we do use the definition, if we assume that our solid object rotates around a fixed axis, and we use the definition to find L rotational of our solid object, then what we will find is that actually the rotational angular momentum of our solid object is equal to this vector. Now, if the object is rotating around the z-axis, then this means that its angular velocity is 0, 0, z. It points in the z direction. Now, using this angular velocity, the angular velocity that points in the z-axis, and what we get for rotational angular momentum of the solid object when it rotates around the z-axis, we get something like this. Now, this is not a vector that points in the z direction. This is a vector that has a non-zero x component, a non-zero y component, and a non-zero z component. What this means is that if this is your angular velocity, then your rotational angular momentum will point in a different direction. It will not point only in the z direction. So the L rotational does form an angle with the angular velocity, which is not the same with what we were saying in introductory physics. Okay, as I said, in introductory physics, we said that the moment of inertia is a number. This is not really true. Now, this is the case that you get for the rotational angular momentum when your object is rotating around a fixed axis. In my next video, I will talk more about what the rotational angular momentum is and the moment of inertia is in a more general case.